Okay, so now what we're going to do is we're going to move on to actually solving the equations that we got on this first page of our notes. And I want to make sure that you can see them. For the most part, what we're looking at here, we actually already solved problem B. That was the same thing that we just did up at the top when we were talking about how to solve linear equations. So all of that work that we did up there, it's literally the exact same equation here. So we're not going to need to go through that one a second time. That being said, what we will need to do is talk about a couple of these guys and then go through that. So as I look at this, we've got 3x plus 5 is equal to 26. Now, observing this, we look and see how many variables are there and where. We got one variable on one side, so we don't have to worry about moving variables at all, which is great. To simplify, we're going to look at both sides and see, do we have any parentheses or like terms that we can combine on each individual side? On this side, we have a 3x and a 5, no like terms. On this side, we've got a 26, it's by itself, so no, we're good. So at this point, what we want to do to solve is we're going to use our inverse operations to move things from this side over there, so we have x by itself, and we're done. We've got a positive 5 there, so we are going to introduce a negative 5 as its opposite to create a 0 pair. And I try to keep this balanced on both sides of the equation. So if I do a negative 5 there, I have to introduce a negative 5 on this side as well. So this zeroes out. We're left with a 3x on that side, which is equal to 26 and negative 5 together are going to give us 21. And the next thing that we need to do is see, how do we get that x by itself? Well, since this is 3 times x, to be able to cancel out that 3, I am going to have to do the inverse operation of multiplication. Opposite of multiplication is division. So I'm going to use divided by 3 on both sides of this equation so that this will then cancel out. 3 divided by 3 is going to give me 1x is equal to 21 divided by 3, which is going to give me 7. So that is probably your most basic type of linear equation, one where you've got number in front of a variable and a plus or a minus something, and then you're going to have a number on the other side. This is a really good way to look through how we would solve something like that. Now, we already showed you how to solve problem B by moving variables to the other side. So now we're going to look at one that has a fraction. This here is like kryptonite to students in this class. And I don't understand why, because fractions are not that difficult, but really what you have to think of it as is you have to think about this as though it's just a giant division problem, because the opposite of division is multiplication. So what we're doing is killing off all the fractions here one at a time. So as we look at this, here's our x. We got one variable there, and it's just on this side, so we don't have to worry about bringing anything over. We see that we can't simplify anything over here because we have a plus 8 and a divided by 2. So I can't combine anything the way that it's set up. I got one number on that side. So now it's just about doing the inverse operations. What I try to do is to see where my x is. Since my x is on top of this fraction here with a plus 8, and that minus or that divided by 2 is all on the bottom here of the fraction, these are completely separate. So when I get rid of them, I have to get rid of this 2 first, so that then I can get at the stuff on the top, and then I'm going to have to get rid of that plus 8. It's kind of like dealing with canceling things out in the opposite order that you have them on. So if I look at this, I've got this 2 on the bottom. The way that you kill off all your fractions is to multiply by whatever number's on the bottom, because this is divided by 2. So what I'm going to have to do on both sides of this equation is multiply by that same 2 to make it go away. This divided by 2 and this times 2 will cancel each other out, and we'll be left with what we have on the top. Now, a big mistake that people make here is that a lot of times people say, oh, that 2, I have to put it there. Nope. You put this 2 here specifically to cancel this 2 out, because that's divided by and that's times. So since they cancel each other out, it goes away and we're just left with what was on top of that fraction. On this right side, I have to complete the work. Negative 6 times 2 is going to give me negative 12. And now I have a pretty simple problem. X plus 8 is equal to negative 12. Again, we're still doing the same steps. To be able to get that x by itself, I have to get rid of the plus 8. So I have to do the inverse or the opposite operation and do a minus 8 or a negative 8 there so that I can have a 0 pair. Do the same thing on the other side because we've got this balanced here. And then when we do this, I can say that this zeroes out and it's gone. I have an x. And negative 12 minus 8 will give you a negative 20. Now, here's the thing. A lot of times adding, subtracting negatives is also something that people have trouble with. What I would say to you is use a calculator, guys. It's fine. Negative 12 minus 8, you'll get the correct answer. You can check with that. Now, we can talk about why that works the way it does, and we should, but this is not a bad way for us to kind of start with this stuff. Okay, it is now asking here, we don't have to solve this, but it's asking if it is a linear equation. Here's what we want to look for. To determine if something's a linear equation, what you're looking for is x, but no x to some kind of power. Now, that means that it's either represented there with nothing to a power, or if I simplify it, like if someplace I have to multiply an x times an x, I would have an x squared. So what I'm looking for here is, as I look through here right now, there are no x's to a power. So right now, that's what we want. This is linear. I'm going to do a quick simplification to see if when I multiply things out and I get rid of parentheses, if anything becomes x squared. As long as it doesn't, we should be fine. So I'm going to distribute. This will be 6x plus 24. This will be negative 2x, and then a negative 2 times a negative 1 is a positive 1. And then I've got 2x plus 20. Now, the way that this stands, if I combine like terms, I'm not changing the variables at all. And that's the only thing I can do to simplify here. So none of these x's are going to become x squared. This is indeed linear, and that's what we're looking for there. Now, the last thing that we need to go through is the first problem on the next page. And what that's going to be is you've got a problem that's kind of worked out, and they're asking you to talk about what the steps are. Now, we can talk back to what we had done in the past here. We talked about commutative and associative and all that stuff, and that's great. But what I'm looking at here is I just kind of want you to describe what you've done in each of these steps. So in the change from this first part to the second part, we had a set of parentheses, then we got rid of them by distributing. So what I'm going to write here first is distribute the 2. Which is exactly what I did. 2 went to x, 2 went to 7, we got 2x plus 14. Now, if I look at the next thing from this side to here, the change is that the 14 stayed the same, but the 2x and the 4x got combined to give me a 6x. And what I'm going to write here is that you combined like terms, because that is what you describe that as when you put together your terms that are the same, your variables, or in this case, we didn't have to do anything with your actual numbers, but you could do that as well. Now, this next side, we've actually introduced something new to both sides. Here we've got a minus 14 and a minus 14 here. Now, you could write this here, subtract 14 from both sides, and that would be fine. I would understand what that meant, and that is describing exactly what you did to solve this. What this is called, this is the subtraction property, and I'm going to write that just so you see it. You can seriously say, I subtracted 14 from both sides. But subtraction property of equality, or an equal sign, basically means if I do the same thing on both sides of an equal sign, I'm fine and it stays the same. Now, if I look here, 14 minus 14 was 0 and it went away. 44 minus 14 is 30. So what we really did was just combine our like terms, and that's what I'm going to write. Combine like terms. And then if you look at what I did here, I divided 6 on both sides to cancel out the 6's here. You could write divided 6 on both sides, or you could say the division property of equality. And that would also be correct. And then when we're done with that, this became a 5, this canceled out and gave me an x, and we got our answer. So we've got these rules here. I wanted to bring them back again so you see them. It's not as important that you remember them, but it is important that you've seen how this works. That's what we've got going for this right now. And so that is what you had to do for this set of problems.